Ever wondered how you actually build a production-ready RAG system from scratch? And more importantly, how learning this skill can take you from a junior developer to a real AI architect? Most developers today think AI is just a few API calls, and magic happens. But if you want to be a software architect in 2026, that's not enough. You need to understand how to ground these models in real data, real systems, and real constraints. And that's exactly what we're going to learn, step by step, here on The Coder Therapist.
Hey, don't worry. I'm right here with you, every step of the way. And today, we're starting an exciting journey toward mastering AI architecture. We're going to demystify something that sounds complex: Retrieval-Augmented Generation, or RAG. Let's start with a simple way to think about it. A standard large language model is like a student taking a closed book exam. It can only answer based on what it memorized during training. But a RAG system, that's like giving the student an open textbook during the exam. Before answering, it can look things up, find the most relevant information, and then respond accurately and confidently. And that's exactly what we're going to build together, step by step, learning, growing, and turning complex ideas into real working systems.
If you want to grow into a software architect, you need hands-on experience with a few core building blocks. In this architecture, we're going to focus on 3 critical layers. First, the ingestion layer. This is where all your raw data lives. Think of it like a giant filing cabinet filled with PDFs, text files, documents, and internal company data. Second, the storage layer. Here's the key idea. Computers don't really understand text. They understand numbers. So we convert text into vectors using an embedding model. This is the quiet brain of the system. It understands the meaning of your words, not just matching keywords, but capturing real intent. And finally, the retrieval layer. When a user asks a question, we don't send it straight to the large language model. Instead, we first search our vector database, find the most relevant context, and then pass that information to the LLM to generate a high-quality answer. And this is the key trade-off. We give up a little bit of speed in exchange for a huge gain in accuracy. Now let's move into the technical side. This is where things really start coming together. To build a system like this from scratch, you need to master the tools that glue everything together. That's where orchestration frameworks come in, tools like LangChain or Llama Index. Think of them as the control center of your application. They decide what happens, in what order, and with which data. They manage the flow between your database, your retrieval logic, and the AI model itself. Without orchestration, everything is chaotic. With it, your system becomes structured, predictable, and production-ready. Here's how all the pieces work together. First, load your data. You use a document loader to pull text from PDFs, files, or internal data sources. Next, split the text. You break the content into smaller chunks. If the chunks are too large, you lose precision. If they're too small, you lose context. Finding the right balance here really matters. Then, embed and store. Each chunk is sent to an embedding model, for example, OpenAI's text embedding 3-small, which converts text into vectors that capture meaning. Finally, those vectors are saved in a vector database like Pinecone or Chroma, and now your data is searchable by meaning, not just keywords. Now, when a user takes an action, like asking, "What is our refund policy?" the application layer doesn't send that question straight to the AI. First, it converts the question into numbers, the same kind of numerical representation we used for our documents. Then it searches the database for the closest matching numbers. In other words, it looks for the most relevant meaning. And finally, it retrieves the exact paragraph about refunds and sends that context to the language model to generate a clear, accurate answer. Now, this is where the real magic happens. Anyone can copy-paste a tutorial and get something working, but to think like an architect, you need strong problem-solving skills and the ability to make tough trade-offs. That's the difference between a toy project and a production-ready application. And the biggest difference? Retrieval quality. This is where you should focus your practice.
First, hybrid search. This combines traditional keyword search with vector search. Why does this matter? Because sometimes users search for very specific things, like a product code or an error ID. Vector search might miss that. Keyword search won't. Using both together gives you the best of both worlds. Next, re-ranking. After you retrieve, say, 10 documents, don't send all of them straight to an expensive LLM. Instead, use a smaller, faster model to rank those documents by relevance. Then send only the best ones forward. That does two things at once. It improves accuracy and it saves money. That mindset, optimizing quality, cost, and performance, is what separates developers from true AI architects. In 2026, building a RAG pipeline is the new hello world of AI engineering. It's the foundation, the starting point, and the skill every modern AI engineer needs. But remember, this space moves fast, so keep learning, stay curious, and stay up to date with what's happening in the industry. You have the blueprint now. All that's left is to take the first step. Thanks for watching The Coder Therapist. If this helped you, make sure to like and subscribe for more deep dives like this. Let's build the future together.